Hello. So now I will extend the model even more. So now we consider two exogenous variables, but both appear in both equations. So the first equation depends on x1 and x2, and the second equation also depends on x1 and x2. So it is a generalization of model 3. So model 3 is a special case of this with this equals to 0, this equals to 0, right? Uh, then, now let's think about the reduced form equations approach. Solve for y1 and y2. Then as before, you have pi11, pi12, pi21, pi22. The problem here is you have four reduced form parameters, which is the same number of parameters in model 3. But in model 3, there are only four parameters to identify. But you have now six. You have six parameters to identify, but you have only four identified parameters from the reduced form equations. Therefore, you cannot identify. That's also a simple failure. And moment condition is the same. You have four moment conditions for six parameters not identified. That's it. And IV approach, even if you would like to use an IV, if you would like to find an IV for y2, there is no there is no excluded variable x1. So the only candidates are y1, x1, x2, but they are all included in the first equation. So there is no valid instrument for y2 in this setup. Therefore, IV approach doesn't work either. Anyhow, there is nothing you can do. So it's interesting that more generalization is not good. So you need appropriate exclusion restrictions. Some variables should have no effect, which is the key assumption. That is the key assumption. And okay, now let's think about. Now I will make some variation from one of the earlier model. So model 2, toy model number 2 was like this. Now I am going to assume beta 1 equals to 0, beta 1 equals to 0, and gamma 2 equals to 0, gamma 2 equals to 0. Then you get this form. So, so it is exactly the same structure as the IV regression model, triangular equations model. Y is determined by x and x is determined by z. So by assuming beta 1 equals to 0, you make x as an excluded instrument. So x does not appear in the first equation. And by assuming gamma 2 equals to 0, you remove the reverse causality. y1 does not affect y2. So that will also enable you to identify the parameter using instrumental variable regression results. And in this case, reduced form now, then, so we know how to identify this triangular equations model. We studied this in chapter 2. But now let's just use the simultaneous equations model approach and see what happens. The reduced form equation now, so from this, the reduced form equation goes like this. By the way, this is the y2 equation is already reduced. There is no endogenous variable on the right hand side. So y2 is already determined by exogenous variable in error term, but y1 need be rewritten like this. So the problem here is y1 is determined by another endogenous variable. So replace the endogenous variable by its function of exogenous variable. So replace y2 by this. And then you have another function of x plus arrow term. So pi is gamma 1 times beta 2, and because you identify beta 2 and pi, and you only need two parameters to identify, it's easy. So beta 2 is identified from this equation, and pi is gamma 1 times beta 2. So pi divided by beta 2 equals gamma 1, which is simple. You may use moment condition approach. There are two moment conditions. X, the only exogenous variable x, is uncorrelated with epsilon 1 and epsilon 2. And then you have this form. And as long as this matrix is invertible, the parameter is identified. The invertibility assumption is this, which requires something times something is not zero, means this should be both should be non-zero. So it should be non-zero, which means correlation is non-zero. It is relevance assumption. And second, the variance of x is non-zero, which is the full rank of the instrument, right? So that is what you can see from the models. And okay, let me really stop here. I will call it a lecture now, and we will go to the next model in the next lecture. See you later. Bye bye.